Right, so now we switch our focus to timelines, right? But before we discuss timelines, I want us to actually switch our focus on the effects of different compounding periods, right? Guys, you've actually seen that in the previous sections, we've only compounded our interest on an annual basis. But that doesn't necessarily mean that that's how things always happen in the real world, right? Your interest can be compounded more than once in a single year, right? Let's just go through the definitions and understand how that is the case. Up to this point, rather, we've dealt with compound interest and depreciation only compounded annually. And as I said, that's not always the case. And if you look at most real-world application, interest is it's most oftenly compounded more than once in a year. I spoke about an example around loans as well as investments. Your interest can be compounded more than once in a single year. And let's say you're basically paying back your vehicle, or you're paying back your house. You have a loan from the bank will need you to pay the money back to them on a monthly basis. Again, that needs us to readjust the interest, so that interest is then compounded on a monthly basis. So, as I said, it is possible to basically compound interest more than once in a single year. And you'll see that in your exams, you are most likely going to be dealing with questions where your interest is compounded more than once in a year. So it's quite important that we understand how to make that readjustment from the compound interest formula that we've dealt with prior. So when this is the case, you have to adjust the compound interest formula to the one below, right? So this is the adjustment you make. You basically divide your interest rate by the frequency of compounding, and then you multiply your time period by the frequency of compounding, right? Let us basically just briefly do an example so that we can actually see how this is basically done. So let's look at this example, right? So remember, M is then your frequency of compounding. In the case where your interest rate is compounded is compounded semi-annually, it means that the M value is going to be 2. Your interest rate is compounded twice in a year. And if your interest rate is compounded quarterly, it means your interest rate is compounded 4 times in a single year. And if your interest rate is compounded monthly, it will have to be compounded 12 times. So M is 12. So if it's semi-annual, M is 2. If it's quarterly, M is 4. If it's monthly, M is 12. And if it's daily, your M is then going to be 365, because we have 365 days in a single year. Now let's continue. Rose invested an amount of 7,000 Rand. Remember, the amount borrowed or invested is always going to be P. Into your savings account for 4 years. You know that 4 is then going to be your time horizon, that's N. So if the savings account offers an interest rate of 7% per annum compound, this is very important, guys. You must always look at this as a key word. And this is compounded monthly. While these guys are then telling us that your M must be 12, because the interest rate is compounded monthly. So determine how much you'll have in 4 years' time. In a nutshell, what we are trying to find here is an accumulated value in 4 years' time. Right, so obviously P is going to be 7,000, right? And then your M obviously is 4 years, and your interest rate is 7%. Remember, you always have to divide that to convert this to decimal, 0.07 rather. That's 7%. And then your interest rate is compounded monthly, so M is going to be 12. So we need to know what is the accumulated value going to be if your interest rate is compounded monthly over a 4-year period. So your interest rate is going to be compounded 48 times over the 4-year period if it's compounded monthly, right? So the formula we're going to use is A equals to P in bracket 1 plus I divided by M raised to the power of N multiplied by M. And then we just substitute all our key values. Remember, I said it's very important that when you read a question, you are able to draw out key values and key parameters that we're going to need to plug into our formula, right? And then I've got 7,000 Rand here. 1 plus the interest rate is 0.07 divided by 12, and then 4 multiplied by 12. Putting this in the calculator should give us a value of 1 plus 0.07 divided by 12, and all of that is raised to the power of 4 multiplied by 12. And that gives us 9,254. So that's 9,254.38. So that's going to be the accumulated value in 4 years' time. So she would have invested 7,000 Rand, but in 4 years' time she will have 9,254. $1,204.38. But now, let us do things like we've been doing where interest rate is compounded annually. So M is going to be 1, right? So let's see what accumulated value is going to be. Remember what we said, the more you compound, the bigger is the accumulated value. So if this was compounded monthly, obviously you'll use the formula 1 plus I to the power of n, because I over 1 is I, and n times 1 is n, which means that m should be 1. Your interest rate is compounded once in a year, right? And I've got 7,000 in bracket 1 plus 0,07 to the power of 4. So obviously I'm just using this to show you that if you're compounding interest more than once in a year, the accumulated value is going to be a lot more bloated than it is right now. So we have 7,000 in bracket 1 plus 7% and raise that to the power of 4. So that gives us an amount of 9,175.57. Clearly, you can see that when we compound more, our accumulated value is going to be bigger than when we compound less. So, yeah, it's very important to understand the frequency of compounding because it really does change the accumulated value that you should get, right? So, obviously, this section is about timelines, but I thought it would be very important to start off by revising or introducing, frequency of compounding because we're going to need a lot of this when we deal with questions around timelines. Okay, so. With regards to timelines, it's always useful to draw a timeline where there's a change in interest rate. To this end, we have never dealt with any question where there are changes in the investment horizon, but it doesn't mean that it's possible. It is possible. I mean, if you get it doesn't mean that it's not possible, rather. It is possible. If you go to a bank, you can actually structure your things the way you want, right? So mathematics should then allow you the ability to be flexible in how you want to assess questions that are related to your interest rates changing, you withdrawing money or adding money in the middle of the investment. We have never done that before in 9.1 and 9.2. So I want us to focus on that, and a timeline can really help you visualize the problem a lot better so that you can see at what point are we then going to have a change. So timelines are very important. We will explore a couple of examples so that you can basically see how you can actually use timelines to help you in questions where there is a change in interest rate, in questions where there is a change in interest rate while in the middle of the investment, or you have any additional withdrawals or deposit also while in the middle of an investment. Now let's switch our focus to the following example, right? Examples. Example 1 focuses on a change in interest rate, and example 2 focuses on a withdrawal. I think there is a withdrawal happening at some point. But guys, let's make sure that we understand what is really important in timelines, right? We always need to focus on the year where a change happens. Let's read the question for number 1. Mpho invests 3,000 Rand into a savings account at an interest rate of 5.5% per annum compounded monthly, right? So after 3 years, remember what we said, we always target the year with which there is a change. That is after 3 years, okay? The interest rate drops to, so there's a change in interest rate. So it has dropped from 5.5 to 3.25. And that's also compounded monthly. You always need to make sure that you follow with how your interest is compounded so that you can know what value of M to use. So how much will she have after 5 years? So it's clear that this investment horizon is going to be for 5 years, right? So if I want to, let me just draw my timeline. So we are saying that at time 0, this person invests 3,000, that's P, right? So this has been invested, so 3,000 has been invested, right? And then after 3 years, there is a change. So let's go 1, 2, 3. So guys, what's going to happen is that we're going to have to accumulate this amount at time 0 to 3 years because that is where some change is happening. And you'll get an intermediary accumulated value, right? And obviously we know that between this, in your first part, in part 1, you know that your interest rate is what? Interest rate is 0,055, that's 5%. But, so that's 4 and 5. And in the next 2 years, which is then going to be your part 2, in the next 2 years, your interest rate now changes to 3.25, so that's going to be 0,0325. Okay? So this is the crux of the problem. All you need to do is to always take your principal amount. You accumulate it to the year where there is a change in your investment horizon. As we can see, after 3 years, the interest rate changes. So this is going to be in two parts, right? You're going to calculate an intermediary A, which then becomes your AP for the last 2 years of the investment, right? So if we look at the first part of that problem, you've got P as 3,000, and then you've got your interest rate as 5.5%. You've got your N as 3 years because the change happens in 3 years, but our interest rate is compounded monthly. So we want to calculate what our intermediary accumulated value is. So we accumulate it to the year where there is a change, right? So you know that we're going to use the formula A in bracket P, 1 plus I to the power divided by M raised by to the power of raised by N times M. And why are we using this formula? Because our interest rate is compounded monthly. Okay, and then I've got A, which is then going to be 3,000 Rand. So 3,000 Rand multiplied by 1 plus, what's the interest rate? 0.055, and that is divided by the frequency of compounding, which is 12, raised to the power of 3 multiplied by 12. So then, after 3 years, our 3,000 would have grown to the following amount after 3 years. So the 3, 1, 2, 3 in bracket, 1 plus 0.055 divided by 12, and all of that is raised to the power of 3 multiplied by 12. So our 3,000 would have grown to an amount of 3,536.85. So this is what this P is going to be. That's A1, the intermediary. This is how much we have, right? But then what happens? Beyond this point, right, our interest rate changes. But what is our new P? So this A1 is then the new P for the final time period, right? 3,536.85. Okay, so looking at the last leg of the investment, then our P then becomes 3,000, because I mean that's the initial amount going into year 5. Okay, your A1 is just the new value of P for the last investment horizon for 2 years, right? So that's 3,536.85, and then so again, what happened? The interest rate has changed from 5.5% to that. And then N is what? N is now 2. Because from year 3 to year 5, there's only 2 years left. And then again, this is compounded monthly, which means that your M is also just going to be 12. So therefore, it means that obviously we're going to use the same formula, 1 plus I to the power divided by M raised to the power of N times M. And then now the P is 3, it's no longer 3,000, it's now 3,536.85, and that's multiplied by 1 plus what's the interest rate? 0.0325, and that is divided by 12, and then 2 to the power of 12. So therefore, it means that after 5 years, with the interest change taken into account, our investment is then going to be, let's see, 1 plus 0.0325 divided by 12. All of that is raised to the power of 2 multiplied by 12. And that's going to be, so it means that after 5 years, she'll then have 3,774.05 into your account. Okay. It could have been more if your interest rate stayed the same. It's just that after 3 years, your interest rate had to be reduced from 5.5 to 3.25%. So that's what the cumulative value is going to be. Remember what we said. You always focus on the year where there is a change. You take the principal amount, you accumulate it to that specific year, and the value that you get, the value of A that you get, is just an intermediary A. You'll use it as P for the next period. Even if we have even more period, that's what you'll be doing. You'll just be going compounding to those particular years, right? So that's what your value would therefore be. So now we then switch our focus to the second example, right? And this is the second example. Obviously, you know what the answer is here, so I'll basically just delete this part, 3,774.5 cents for space. I'll delete this part for space now because I need to do example 2. So now, example 2 is more concerned with withdrawals. Remember, timelines, we are concerned with change in interest rates as well as addition and withdrawals. So the next example then focuses on addition and withdrawals, right? Again, remember what we focus on? We focus on the year where the first change starts happening. Okay, so 20,000 Rand is deposited into an account which offers an interest rate of 9% per annum compounded monthly. 2 years later, so you see that change is going to happen in 2 years. Okay, so that's let's try to draw a timeline for this one, for number 2. Okay, let's just give it a little bit of space. Cool. So at time 0, 20,000 is deposited. So remember, P is always the amount borrowed or invested. So we've got 20,000 Rand at time 0, right? And where does the change happen? 2 years later, at year 2, 5,000 is withdrawn. So we'll need to accumulate this to year 2 and get an intermediary, accumulated value. But what happens here is that we need to take away 5,000. This person is withdrawing 5,000 from the account. But you first need to accumulate the 20,000 because it earns interest over 2 years. Then you'll subtract from that A1, and then let's see what happens with the rest of the question. 5,000 is withdrawn from the account. How much will be in the account after 8 years? So that's 3 up until you get to year 8. Okay, so we want to see what happens after 8 years, right? So that's the final accumulated value. Okay, so obviously between 0 and year 2, that's going to be the first part of the question, and from year 2 to year 8, so that's going to be the second part of the question. Okay, so let's do the first part. Remember, your question is progressive. You keep, this is the final answer is the final answer at the end, so it becomes progressive. So now let's first calculate this. So P is obviously 20,000, and then so for the first part, so N is 2, and then the interest rate. So the interest rate doesn't change, so it stays at 9%. So that's 0.09, but the frequency of compounding is monthly, so M is then going to be 12. So we need to know what is our intermediary accumulated value before we withdraw 5,000. So then we have A, which is equals to P in bracket 1 plus I divided by M raised to the power of N times M. Okay, what is P? P is 20,000 in bracket 1 plus, what's I? I is 9%, 0.09, and that is divided by M, which is 12, and obviously that's the first part is 2 years, so that's 2 multiplied by 12. So after 2 years, your 20,000 would have grown to, after 2 years, your 20,000 would have grown to, let's go 20, bracket 1 plus, 0.09, and that's divided by 12, and all of that is raised to the power of 2 multiplied by 12. So that is 23,000. So after 2 years, your 20,000 would have grown to 23,928.271. Okay, this is how much I have in 2 years' time. But something happens there. I withdraw, right? I need to withdraw 5,000 Rand. So I have to take away 5,000 Rand from this. Take away 5,000. Okay. And therefore, that leaves me with an amount of minus 5,000. So it means after I've withdrawn, now I have my new P for the last investment horizon, which is then 18,928.271. Okay. Now we focus on the last part now, which is the last part now. So the P is then going to be 18,928.271, and then the interest rate doesn't change, so it stays at 9%, and it's compounded monthly, so M is 12, but what's N going to be? So there's a change, so from 2 years to year 8, it means we have 6 years, right? So now let's calculate our, obviously now we know the A is then at the final accumulated value after 8 years. So then you've got A, which is equals to P in bracket 1 plus I divided by M raised to the power of N times M. And then our A is then equals to, so the P is now, because we've withdrawn the 5,000 in 2 years. So that's 18,928.271, and that's multiplied by 1 plus interest rate is 9% over 12 to the power of 6 times 12. Okay, and therefore it means that after the 8 years, this is how much you'll have in the account. 1 plus 0.09 divided by 12, and all of that is raised to the power of 6 multiplied by 12. Okay, so that would mean that after 8 years, there will be 32,415.66 into the account. And obviously the amount would have been a lot more if there was no withdrawal in year 2, right? But again, as I said, the solution technique is basic. You always target the year where there's a change. You accumulate your P to that year, and then you make the adjustments, and the rest of the investment will then apply additional information. So basically there is timelines, there isn't nothing untoward to it.